creating atomic models. In this video, you are going to first identify the number of protons and neutrons in the nucleus and how many electrons for each atom. But then taking that information, you then are going to draw and identify the charge of protons and neutrons in the nucleus, and then in the outer energy levels, you're going to identify how many electrons can be for each energy level for your certain atom. We're going to begin with the element oxygen. So we're going to start by identifying the numbers of protons, neutrons, and electrons in the atom for oxygen. So I remember to find the number of protons, I had to look at my atomic number. So I'm going to start filling that in. And what I also recall is for Matterville to be stable, the number of protons has to match the number of electrons. So guess what? Matterville's stable. Now I need to figure out the number of neutrons. So what I remember is if I take my atomic mass, that's the mass of the nucleus. So the mass of the nucleus of oxygen. So if I take that number and I round it to the ones place, so if that 5 looks at the 9 tells that 5 to go higher, so it's going to be 16. And I know my nucleus is made of protons and neutrons. So I don't know my neutrons. It's empty. So I do know my protons. So I'm going to do 16 minus 8, which is my protons. Let's put a little p there. Okay. 16 minus 8 is 8. So this is going to be my neutrons. So I have 8 neutrons. And just remember, protons and neutrons do not always match. So don't immediately fill that in. Now that we know the numbers of protons, neutrons, and electrons, we can start drawing our atomic models. So I'm going to begin with my nucleus, and I know I have 8 protons in my nucleus along with 8 neutrons, so I always start with my protons. So I'm going to draw 8 protons. 1, 2, 3, 4, 5, 6, 7, 8. And because they're protons, they're positive, so we got to put the positive charge in the middle. Now I need to put 8 neutrons also. So I'm going to try to cluster them as well as I can. So 1, 2, 3, 4, 5, 6, 7, and 8. And because neutrons have, they're neutral, there's no charge, you don't put a charge in them. You just leave the circles. Now we're going to add the electrons. So electrons are on energy levels, and based on notes that we've taken in the past, only 2 electrons can be on the first energy level. So I have 8 electrons, but only 2 can go on the first. So I'm going to draw 1, 2, and I have to make them negatively charged. So I got to put my little negative sign in them. So I need 8 minus 2 is 6 more electrons. So I've got to add another energy level. And then I'm going to try to do my best to make my electrons about the same size. So I need to add 6 more because on this energy level I can have a maximum of 8, but I only need 6, so I'm only going to draw 6. So 1, 2, 3, 4, 5, 6, and because they're negative electrons, I've got to put little negative signs, negative charge, which helps keep those positive protons inside because those negatives are keeping those positives in the nucleus. So I'm going to count my electrons just to be careful. So 1, 2, 3, 4, 5, 6, 7, 8. And so we have just created an atomic model for oxygen. To see how well you are at identifying the numbers of protons, neutrons, and electrons and creating atomic models, on a piece of loose leaf you're going to create the atomic model for boron, but first you have to figure out the number of protons, neutrons, and electrons. And then you're going to draw the atomic model, make sure your protons and neutrons go in your nucleus, and your electrons are on the different energy levels. Do not forget the charges, and you will be turning this in, so take your time. Good luck! Now I have a challenge for you. For the element aluminum, you're going to identify the number of protons, neutrons, and electrons for the atom. but you're also going to create that atomic model. However, this time I'm not giving you the energy levels. So here's my one hint based on some notes that we've taken in the past. The first energy level can only have a maximum of 2 electrons. The second can only have a maximum of 8 electrons. The third can only have a maximum of 18 electrons. And the fourth energy level can only have a maximum of 32 electrons. So I just want to see who is up to the challenge of drawing an atomic model for aluminum. You will be turning this in, so make sure to take your time. And remember, if you need help, re-watch the video for how we solved it for oxygen.